Okay, so next line. Hands up, who knows what to write on the next one? About half of you. Let's go, Zach.
You would write equals the limit as x approaches 0, and then probably try to factor it, put it in factor.
For sure. We don't do item 1 because we're not finding the limit as x approaches infinity. We do need to try and see if we can factor. For our class, the factoring is really, I've never seen a factoring problem that was really difficult. I always look for simple factoring first, which is when I look at this numerator, I see 3 terms. Each term is composed of factors, and each term has a factor of x. So that's the first type of factoring I'm going to do, is pull out the x. 2 for Zach. Raise your hand if you know what comes after the parenthesis, hands up. There we go. Get a few more. Let's go, Noah. Keep going, Noah. You're good.
5 minus x minus 4x squared.
Perfect. Point if your hand was raised. 2 for Noah. Who knows what's on the bottom? Quick. Faster here. A few more hands. Let's go, Jared Humphreys.
X. Parentheses 3 plus x plus 2x to the third power.
3 points for Jared. Well done. 2 points for your hand was raised. Questions? Please, Caleb.
Can I go?
Take it back.
Can I get a drink?
Yeah. Thank you for asking. Yep. Perfect. Okay, here's a trap they're trying to set for you. Don't get so kind of stuck on the idea that you need to factor that you necessarily just jump right in and try to factor this. That at a glance is harder to factor because of the negative, because of the 4. So I didn't really think to factor right away. I'm going to go with the next thing, which is check left and right first, see if that helps me progress. So again, for clarity, I'm going to write the factors separately, like this. Then I can look at each factor separately. Questions from anyone? Solid. So,
Where is this?
please.
Sorry.
Go ahead, Caleb.
Approaching 0. Are we doing it from the right, from the left, or something completely different?
3 points, good question. Whenever you see this written, your brain has to say, this is talking about left and right. We haven't necessarily broke it out, but it is always talking about left and right. So I think to myself, okay, if I choose an x that isn't quite 0, it's slightly more or slightly less than 0, this yellow box will have some value, and this green box will have some value as well. Whole room, raise your hand. What will the value of the yellow box be if you choose an x that is not 0, but it is almost 0, which is what we do when we're finding a limit? What's the value of the yellow box going to be, Marin? So Marin votes 1. Who votes with Marin? 2 points, 3 for Marin. Green box. What's the green box going to be when x is almost 0? So you're picking an x, really close to 0, slightly more, slightly less. You're putting that x here. You're putting that x here. Same x goes here and here. And you're just kind of trying to find out, first of all, like, what's this numerator going to equal? So this part right here, oops, blue. What's that going to equal? And then you look and say, okay, what's the denominator going to equal when x is almost 0? Not quite, but almost. Hands up. There we go. More. Let's go Jared Bergen. Such. Jared? It is Bergen.
It is very.
Jackson. Yep. That'll be for the wrong name. Good news was, as soon as I said Jared, like, that ain't right. So go ahead.
It'll be 0 for the numerator, and then, I don't know.
Let's talk through it a little bit. So we're going to put a 0, not a 0 exactly, but close to 0 here, and then close to 0 here as well. This blue box, Jackson, do you see terms or factors?
Term.
Good. So the terms are adding. So what's this term going to get very, very close to equaling as you plug in a value of x that is very, very close to 0?
So it'll be close to 0.
Perfect. How about this one?
That one will be close to 0.
Awesome. So this part's close to 0, but then we add it to 5. So what's the numerator close to?
So it's going to be close to 5.
Does that make sense? 3 points.
Yeah, I was just gonna say it's 5.
And then how about the bottom, Caleb?
Would that just be 3?
The bottom would be very close to 3. 2 more for Caleb. So we're done. As x gets close to 0, the yellow box is 1 exactly, not close. The green box is very, very close to 5/3. Therefore, the limit is precisely 5/3. Please.
I don't really realize 5/3. I was thinking that I was going to be like 1/5 because 5 minus, but I guess 4 times. Okay, wait, never mind. I think I just talked
Talking
to
about
myself.
Hey, it's really one of the smartest things you can do. It's like that's why I keep saying, like, the whole point of this is just to get you talking.
Wait, wouldn't the numerator
Does that make sense?
be negative?
Yeah, it makes sense.
Go ahead.
Sorry, Jeremy.
You're good.
Would the numerator be negative?
Tell me why it's not, but tell me why you thought it was.
Since it's 5 minus x.
But what value does x have?
Close to 0.
Close to 0. So if you take 5 minus close to 0, what do you get? You're just thinking of it backwards. Like, think of this as just being 1. What would 5 minus 1 be?
Oh, sorry.
No worries. You see it now?
Yeah.
You're good. 2 more. Yeah, like I was saying to August, really, I just want you to talk. Like, because when you talk, you figure it out. Like, I'm just here to kind of just say, oh, let's adjust that a little bit, or hey, you didn't really think of this, or oh no, perfect. So just the more you talk, the better. Grace, please.
So last time we were like almost just picking like the biggest, the one with the biggest exponent and just keeping that. Why didn't we do that on this problem?
3 more points. The step we take, Grace, where we say we're going to pick the term that has the largest exponent compared to something it's adding to is only applicable if the limit we are asked to find is x approaching infinity.
Okay.
So in this example, x is approaching 0, therefore that idea isn't valid at all.
Okay.
Does that help a little?
Yeah.
Please, Mary.
This is probably a dumb question, but because it's not exactly 5/3, why don't we do like the squiggly line?
It's actually a really good question. If you were making a table like this, Marion, and you'll see me do this all the time. If I'm close to 0, so I'm not 0, but I'm close, like slightly negative or slightly positive, the value of the y-coordinate will not be exactly 5/3. It will be extremely close, but it won't equal 5/3. However, when you're finding a limit, the answer to a limit is, what value are we getting close to? We're getting close to 5/3. So we write the limit as equal. It's just a subtle difference between what is meant by limit as opposed to what is meant by actually finding the xy pair. Help a little? It's a little funny, but anybody else? Okay, cool. We need to find the value of the function still at x equals 0. So we need to find f of 0. You've got 3 choices. You can use the black formula. You can use the blue formula. Or you can use the formula down here at the bottom. We'll call it the purple formula. Right here. I prefer the purple Because I can say if x is exactly 0, yellow box is undefined. And I don't care what the green is, undefined times whatever is undefined. So my f of 0 value is undefined. Question. Please. Go ahead, Elsie.
So why on some problems do we say the limit of f of x over x, like as x approaches 0, and some we just do the limit? Does that make sense? Sometimes we write f of x and sometimes we don't. So
Your question's really good. I want to make sure I haven't misled you somewhere. So your recollection is that somewhere we've been doing problems and I've only written this much here, like with nothing after it. Is that what you're thinking? So if that's, yeah, somehow I misled you on that one, so that's my bad. You can't have a limit of nothing. Yeah, it has to be the limit of something. And what I'll go back and forth, usually what I'll toggle between is, sometimes I'll just say, let's find the limit of f, because I just don't really want to write this whole big formula. F and that big formula are the same thing, so I could write either one. Another thing I do that can be confusing is sometimes I'll write limit and then I'll write over here like the formula to the side, kind of. It's the same thing. Does that help a little bit?
yes.
Okay, that's much better. So you were thinking like when I wrote it this way, how do I say it? Like when I put the limit, like the f way up here, that's kind of one thing, right?
Yes.
And then when I wrote it, say like this way, it looks like two things.
Yeah.
Fair. Good question. 3 more. It's the same thing. Does that feel better? It's good work. Please.
When we do these, is like the f of whatever the x value is it always going to be undefined? Like for the past,
It's been on a lot.
yeah.
It's not every time.
Okay.
For this pink packet, it's going to happen a lot, but it isn't every time. Yeah. 2 more. So here's our conclusion. Let's go here. So here's the conclusion to 6. And Ellie Wagner. Okay. Ellie is correct. In this case, we're back to a removable discontinuity. So, and on the pink, that's really common, but not always. And on a test, you won't know whether it's kind of more of a buff packet problem or a pink packet problem or yellow. So. Cool. Next one. Making good progress. We'll leave that for homework.